something that you can do to help yourself with these guys. So we have this right triangle, and we have the altitude of it, which is a right angle as well. Yeah? There's three scenarios. Being a geometry teacher, I think it makes it easier if you label things. If you don't need to, it's not a big deal. Okay? So the values that are going to be squared are either this guy right here. It's always going to come from that vertex there, that right angle, or this guy. Okay? Those are going to be the lengths that get squared. Okay? So, if we start off with this first guy, I'm going to color code everything because color coding makes things easier. So if I'm taking that AB length and squaring it, the other two lengths that I need have to be attached to that vertex. So what two lengths are attached to that vertex? B to C, and what else? B to D. Okay? Yeah? If, what other colors we got here? Purple. Let's go. If I've got A to C that I'm squaring, so I've got this guy, what vertex do you think it needs to be attached to? C. So what two lengths are attached to C? This guy right here, good, B to C, and C to D, good. Yeah? Alright, and then the last scenario, if I've got A to D, take a wild guess what it's got to be attached to. It's got to be attached to D. So what are my two lengths? D to B and D to C. Good. Okay? So we're always attached at a common vertex. Alright? You want me to leave that there for a second so you can get it? Alright, go ahead. Yeah, I am. Alright, so let's put this into play. So, what side length is going to get squared here? X is going to get squared, and what other side lengths do we need? We need 36, and we need, it's got to be from this vertex, right? So we've got 36. What's this whole length going to be? You're going to have to add the two parts together, right? Part plus part equals whole. If you're heavy for geometry, you heard that a lot. So what's these two added together? 100. So this guy's only there to help you get the 100. Does that work? And what do I do? Multiply these guys and then square root everything. So x equals 60. Good. Okay? What gets squared in this guy? The x again. Off of this right angle, yeah? The main right angle. And then which two are touching this vertex? So if you need to label it, you can. Yeah. You would. Or you just don't have two scenarios and either one will work. Yep. So what two side lengths do I need? A to what? I need A to B and I need A to C. Which of those values do you already know? I know 25. Do I have the length between A and B? No, but you can subtract them and figure it out, and it's 9. Does it make sense that this guy we add them, and this guy we subtract them? How do you tell which one you do? Which part's missing? Yeah. We were missing the whole thing, the total. So we had to add them together. This one we were missing a part. So we had to subtract it from the whole thing. Those are my girls. Yeah, then ignore that. Then you're going to subtract. Yep. Yep. 9 times 25. If you have 9 quarters in your pocket, how much money you got? 225. And if you square root the whole shebang, you get 15. Very nice. So far, so good. Not too bad. How do you feel about that third one? Okay. We're all still front. Cool. All right. What do you got to do? We have to solve for x. Okay? Which numbers can go together, can correspond together? What do you have to create? What does your equation look like that you're going to make? It's going to be a cross-multiply problem. It's going to be a proportion. Okay? So what things are going to go together? 6x plus 12 plus, where's 28 coming from? So what value, where does that go on my picture? It's from where to where? From, yeah. From P to R, from R to P. So if I add these guys together, right, you're just combining like terms. So I've got 6x, and then 12 plus 16 will give you 28. Does that make sense? Not too bad? You can do the same thing if you want to figure out this part over here. What you would do to what? To these two numbers? You subtract them, right? So this guy's a part. Okay. Which ones compare to, which one of those do I have to use? I have to use. What's the whole purpose of this? You have to use 6x plus 28. You want to solve for x, right? So x has to be involved. So then you need things that 6x plus 28 have something in common with. So what do you use? You can use 121 because they're both from the big triangle, right? So 121 can go here or it can go here. It does not matter. It will not make a difference. What else goes with 6x plus 28? It's what side of your triangle? You've got, these are both from the big triangle. We have to compare it to what other triangle? The little triangle. So 16 and 22, which one's going to go with the 6x plus 28? 16, because they're both on the left side. Does that make sense? So they have something in common. They're both from this side of the triangle. They're corresponding sides. And what else goes with 16 and goes with 121? The 22. And then you do a little cross multiply. You could have done 110 and 20. You could have simplified them down to 11 over 2. It does not matter as long as when you cross multiply, these guys are across from each other, these guys are across from each other. Okay? Can somebody do the math for me here? Because I don't have a calculator with me. 132x? Alright, what else? 616? It's got to be bigger than that. This multiplied by this is only 600 and something? Oh, okay. What about 16 times 121? Good. Subtract this guy. 1,000 what? For each zero? Oh, that's going to divide so nicely. That's like a, that's a gift right there. Look at that. That's going to divide so nicely. What's your answer? 10. It's 10. Boom! Cool. Anything particularly terrifying? Not too bad? Kind of okay? Sort of alright? Alright, we're going to go over that geometric